This video contains an exercise that you have to solve. So I'm going to take a moment to explain the instructions, the goal, and then I will give you the opportunity to pause the video and you can then solve this exercise on your own. And then when you're ready, you can come back and watch me solve this exercise. Okay, so the title is Matrix of Integers. What you want to do here is create a matrix of numbers. It should be a 4x6 matrix. So that means 4 rows and 6 columns. And the matrix should contain random integers. But these are not just any integers. They have to be drawn from a distribution between 5 and 17. So the smallest number should be 5, or the smallest possible integer should be 5, and the largest possible integer should be 17. And then the numbers can be randomly drawn between these two numbers, and they should all be integers. And then once you've created this matrix, what you want to do is calculate the proportion of even numbers and odd numbers in this matrix. Now, it's not necessarily going to be 50-50, because these are going to be random integers. Of course, you would expect this to be roughly half because we are... Oh, actually, never mind. That's not true. You wouldn't expect it to be roughly 50-50 because there's actually more odd integers than even integers in this range when we include 5 and 17. Anyway, the point here is to write some code to get these two parts of the exercise. So now is your opportunity to pause the video and write some code. And now I'm going to walk you through my solution. So I'm going to start doing this by soft coding. So I'm going to specify the parameters that I want to use in this exercise. So I'm going to make this matrix be M for M rows, and N columns is going to be 6. And then I'm going to, actually maybe I'll put another comment here. So I'm going to write list the soft coded parameters. So this is the number of rows. This is the number of columns. And then I want to specify the lower bound, I'll call this lower BND, equals 5. And then we have the upper bound for the numbers that we're going to be drawing from is 17. Okay, so now we've listed the soft-coded parameters. And what I want to do now is create the matrix. So how do we create a matrix of random integers between 5 and 17? Let's start off with a slightly simpler problem, and I'm just going to create a matrix of random numbers that's the right size. So let's call this matrix M, and it's going to be, I'm going to use the rand function and input M and N. Now, this is not solving the problem, but an important aspect of coding, an important strategy in coding and problem solving using coding is to solve problems one little step at a time and only move forwards one more step when you are confident that you've gotten the first step correct. So this is not yet the correct solution, but what I want to do is just make sure that this is really going to be a matrix, a 4x6 matrix of numbers. So I pressed Control Enter on the keyboard, and that runs all this code, and we see there's 4 rows and there are 6 columns. Now, these are not integers, so they are random numbers, but we need integers. So if I want to make these be integers, I can use the round function. So I'm going to round all of these numbers. Now, because the rand function gives us numbers that are uniformly distributed between 0 and 1, when I round all of these numbers, they're only going to be 0 and 1. So they either get rounded down or to 0 or rounded up to 1. So that's still not really correct yet. So what I'm going to do now is multiply these random numbers. So these are uniformly distributed between 0 and 1. So if I multiply them by upper bound, so I'm going to say times upper bound, this is going to give me a matrix of random numbers between 0 and 17. And then I round those. So let's see what that looks like. Okay, so we are getting there. We have a matrix. It's the correct size. It is all integers and it's random integers. So that part is good. However, we need to go between 5 and 17, and these can go all the way down to 0. So what can we do here? Well, we can add the lower bound, so plus lower bound, And now we're not going to get any numbers smaller than 5, so now we are respecting the lower bound. But of course, if these numbers can go up to 17, then we add another 5, so then we can actually get numbers that are larger than 17. So in fact, what we need to do is subtract the lower bound, so upper bound minus lower bound, inside here. So this actually ends up being random numbers between 0 and 1 that are multiplied by 12. Notice we actually need these parentheses here because we need this to be one expression. So now we get numbers between 0 and 12, and then we add 5, and that gives us our numbers between 5 and 17. And now I can confirm this. I'm going to use the disp command, and essentially what I want to do is report the smallest number in this matrix and the largest number in this matrix. So the smallest number in this matrix, you can think of using the min function, and I've already introduced you to the max function in a previous video, and I mentioned that the min function works similarly. But if we type min m like this, we actually don't get the smallest value, the minimum value. We get a whole vector of minimum values. And actually what's happening is that the min function is working column-wise. So this is telling me the minimum value in column 1, the minimum value in column 2, the minimum value in all these individual columns. Now if we want the global minimum from the entire matrix, there's two ways to solve this. One is to take the minimum of the minimums. So that would be min m, and that tells me that the smallest number anywhere in this matrix M is 6, so that works. Another thing we can do, another solution to this little problem, is to do something called vectorization. And vectorizing a matrix means to stretch out the matrix into a vector. So here we have the matrix in like this sheet. It's spread out in this 2D sheet, but we can take this column and put it underneath this column, and then take this column and put that underneath those columns. And the way we do that is by putting a single colon inside parentheses after the matrix. So this looks a little bit like indexing, but we are indexing everything in the matrix. And this gives us one vector that corresponds to all of the elements inside the matrix. So that's a linear algebra operation called vectorization. And then we only need one min. So we can do it like this. So there I showed you two ways. I'm going to copy and paste this. So we want the min, and then we want the max, like this. So now this is going to print out I think I will put a semicolon at the end of this line to suppress the output, because we don't actually need to see all of these numbers here. So each time I run this code, it's going to generate a new random matrix, and we can see that the minimum is 5 and the maximum is 17, and they are all integers. All right, so that was pretty cool. That solves the first part of this problem. Then we get to the second part of this problem, which is to report the proportion of even and odd numbers. I'm actually going to comment this out. This was not part of the instructions. That was just a check for us. Okay, so how do we get the proportion of even and odd numbers? Let's start by thinking about how we get even and odd numbers from this matrix. Well, I've already shown you this trick using the modulus in a previous video. So we can write, let me start this down here actually. So we can write mod m, comma 2, and that's going to return, so just to be clear, so m is our matrix of integers, and then if I say mod m, comma 2, what that's going to do is divide each matrix element by 2 and report the remainder. So the remainder is either 0 or 1. And I've already explained that when you divide a number by 2, if it's an even number, the remainder after division is 0, or the modulus is 0. And if it's odd, then the modulus is 1. So all we need to do now is count the total number of zeros in this matrix. That's the total number of even numbers, even numbered elements in here. So, and then I'm also going to vectorize this. Let's say mod m vectorized, and it's vectorized that's going to make it more convenient for the next step that I'm going to do. So mod m2, now this gives me a bunch of zeros and ones, again, this is for each element of the matrix and it's vectorized, and all of the zeros correspond to even numbers and the ones correspond to odd numbers. Now I want to count the total number of zeros in this vector. So how can we do that? We actually need to flip this around. I want to say equals 0. So this is going to tell me where are these elements equal to 0. And then I need to sum all of these up because I want to know exactly how many there are. So we see in this particular matrix with this random numbers, there are 9 even numbers, 9 even integers that were randomly drawn between 5 and 17. Now that's good, but we need the proportion. So how can we convert this sum into a proportion? Well, to do that, we just need to divide by the total number of elements in the matrix. So how do we know how many elements are there in this matrix? Well, we can use a function. We can say divide by numl m. That's totally fine. That's a good solution. But we also happen to know directly how many elements there are because it's an m by n matrix. So we can also solve this problem without using any functions, just by multiplying these two numbers. Okay, so this tells us the proportion. So it happened to be in this particular matrix that there is 50% even numbers. I'll run this again. Now there's 58% even numbers and so on. Okay, so we need to report this. I'm actually going to set this to be a variable. Let's call this n even. And now you can probably guess what I'm going to do next. Copy and paste. I'm going to call this variable n odd. And then this is really important. You have to change this from a 0 to a 1. Notice also I added a space here. This is totally correct. There's nothing wrong with how this code looks now, but I think it looks nicer. It's cleaner. The code is easier to read when the equal signs are aligned, because then all of these functions are aligned. That makes it easier to see what is the difference between these two lines of code. This is an aspect of coding style that doesn't change the code itself. It just makes your code easier to read. Okay, so now we have our two variables and we need to report them. So I'm going to use the disp function and I will say n even. Let's say I'm actually going to convert this into percent. Percent even numbers and n odd percent odd numbers. Okay, now I've already mentioned in a previous video that this sort of thing is not going to work. And that's because Matlab is interpreting this number 0.45, or trying to interpret this number, as an ASCII code. But there is no character, there's no letter or alphanumeric character that corresponds to an ASCII code of 0.45. In fact, what we want to do is convert this from a number into a string. So I will write num2string here, and then we also need to write num2string here. And so I'm doing this with the disp function. In the previous video, I introduced you to the fprintf function. So you could also solve this using fprintf. Now, we're not quite done. This is not quite accurate, and that's because there isn't 0.375% even numbers. It's actually 37.5% even numbers. So to convert proportion into percent, you just need to multiply by 100. So let's do this. And now I'm pretty sure that this is correct. Let's see, I'll even put in a clear screen here so we can get rid of all that visual noise at the top. So in this run, this random matrix, it happened to be 37% even numbers and 62% odd numbers. And here's what that matrix happens to look like. Cool. So I hope you enjoyed working through this exercise. I hope you found it a nice balance of challenging but also still feasible. Stay tuned. In the next video, we're going to have another exercise that's going to be a guessing game. We're going to program a guessing game into Matlab.